Hello everybody, very warm welcome to Vedantu JEE English channel. What's up, how are you all? After a long time I'm coming live, isn't it? Haven't seen you guys live for a very long time. Okay, so what if I told you that I have the mantra for you all to get at least 65 marks in your chemistry exam? You won't believe me, right? But believe it or not, I have it right here, the most repeated questions. In fact, I even matched it with the sample paper this year and I saw that yes, the repeated questions were, in coordination with the sample paper. So, let's solve it and let's ace our board exam for chemistry. We have already aced JEE exam and we are preparing for JEE 2023 even for April. Why to lag behind in board exam, right? Let's get this done as well. Everybody ready? Quickly go call up your friends as well. I have already texted in the Telegram channel. Please share it with your friends so that more students can get benefited. And let's take a look at the most repeated questions of CBSE grade 12. Okay. Alright. Chalo. Let's take a look at it, everybody. Are you all here with me? Why is this not? This is not changing. Okay. Now it changed. Yeah. Now that you all are here, those students who are old, don't forget to like this video, and those of you who all are new here, do not forget to subscribe to this channel. Yes, can I see you? I'm not seeing your chats. Where are you guys? Where are you guys? Hi everybody. Hello. Now I can see. Come on, quickly go call up your friends, everybody. Quickly call up your friends. There you go. Amazing. Okay, all right. You are new to my live. Yes. That means that you are supposed to subscribe, because Vedantu JEE English channel is one channel where all the information that are related to your class 12 and class 11, JEE or EMCET or CBSE boards, everything is provided to you in this channel in English language. Okay, all right. Does this video contain all lessons? Yes, all lessons, bacha, all lessons, every chapter that is included in your syllabus, we have a question right here. Okay, so quickly go share it with your friends, call up your friends, subscribe to the channel, and now yes, there will be a session for electrochemistry. I think it's too late for us to start a session on electrochemistry. So what we are going to do is we're going to solve the questions rather. Okay, can I get 95 plus? Absolutely, why not? Try. Okay, so let's get on with it, guys. And the first question, okay, the first thing that I have noticed is in most of the previous year questions, either they have asked you the definition for molality, or they have asked you definition for molarity, or they have asked you the definition for mole fraction. You can also see in which year it was repeated. Do you check it out? Yes. Everybody, are you all able to see this? See, molality was asked in 2017 and 2014. Molarity was asked in 2017 and 14. And mole fraction, the definition of mole fraction was asked in 2014 and 2012. Okay. All right. And now, let me tell you that even if you check out the sample paper, you will find questions that are related to these terms. If they have not asked you the definition, if the definition has not been asked, there is definitely a question that is related to these terms. Because we know that from physical chemistry, yes, from the chapter solutions, these terms are the most important. Okay. All right. So, let's check it out. Yes, what is molality, my dear student? We all know the definition of molality. Do we know this? Can I get some thumbs up in the chat box if you know this? Everybody, come on. Give it to me. Yes, let's check it out. Yes, come on everybody. Should I watch these repeated questions? Yes, you must watch this repeated question. At least you will be able to solve some questions. Okay, solve some questions. Don't worry about it. Yes, great. So molality is always denoted with the letter small m, not capital M, small m, starting from the very basics, everybody. Molality is given to you by small m, as you can see. Okay, and how is the definition? The definition is number of moles of the solute per kilogram of the solvent, okay, and is expressed as. If you still cannot remember the sentence, all right, no problem. You want 1 marks? Write this down. Write at least this down, okay? This formula. This formula you have to write it down. Molality, small m, is equal to moles of solute divided by mass of solvent in kg. Can you at least do this much? Can you at least do this much, everybody? Yes? Can you do this much at least? Or no? This much also will not go into your head. You can go this much, right? Great. Amazing. Next, molarity. Molarity is denoted with capital M. Okay. Molarity is denoted with capital M. So check it out. It is the number of moles of the solute dissolved. Say, moles of the solute dissolved per liter of the solution. Yes. Number of moles of the solute dissolved per liter of the solution. That's it, you have to remember. Number of moles of solute. Where is the solute dissolved? In the solution, right? Solute is dissolved in the solution. Yes? In how much? Per liter. That's it. Easy? Easy peasy biryani is tasty. Write that down, everybody. Write that down. Also, if you have to write down the formula for molarity, here it is. W into 1000, okay, W into 1000 divided by molecular weight of solute. Whatever is the solute that is given to you, write the molecular weight of solute into V in milliliter. Volume is in milliliter. Volume is in milliliter, not liter. If it is given to you in liter, convert it into milliliter, okay, convert it into milliliter. All right. Yes, clear hai? This much is clear, everybody? Great. Moving on. Mole fraction. What is mole fraction? Mole fraction is a fraction. In this thing itself, in the term itself, you can see fraction. So what will fraction be, bacha? Fraction means that it is going to be a ratio, right? Even in mathematics, we have learned, right? Fraction, fraction, fraction. Fraction always means ratio. So it is ratio of number of moles, once again, moles of solute or solvent. It can be calculated for solute or solvent, yes, and total number of moles of solution. So basically, solute divided by moles of solution, or it is solvent divided by moles of solution. Understanding? Okay? Great. Amazing, everybody. Bro, this is not recorded, this is live, okay? See, and how is this denoted? This is denoted by chi, okay? This is denoted by chi. So see, chi solute is N2 divided by N1 plus N2. Remember that the letter B or the number 2 is always used to denote solute. For solvent, you usually denote it with A or 1, okay? So, chi solvent is N1 divided by N1 plus N2. Clear? Yes? Clear, bacha? Clear? Yes, Pranjal, yes, you can also watch it. No worries, okay? Yes, got it? Clear hai, everybody? Yes, come on. Yes, Ajay, the PDF will be uploaded. Don't worry about it. Journey of life, absolutely right, okay? From DNF blog, don't worry. I will tell you that also, okay? I will tell you that also, don't worry. Yes, I will tell you that, don't worry. Clear? Everybody is clear with it. Great. Moving on now, okay? Now see, these kind of questions, okay? Either they will ask you for boiling point or they will ask you for freezing point, yes? Or, you know, remember those cryoscopic constant, ebullioscopic constant, all of these? Yes, Wasim sir had taught you, isn't it? Yes, we will discuss Colrush law. There is a question about that also. Don't worry about it. Yes. So either they will ask you about boiling point or they will ask you to find the dip, dip in the freezing point, elevation in boiling point, or they will ask you to calculate the boiling point, or they will ask you to calculate the freezing point. These type of questions are always there with the and check it out. 2011 this question has come, 2014, 2017, 2014, same kind of question, just that what they have done is they have changed the numerical values. Yes, they have changed the numerical values, that's it, and they have changed the name of the compound. So shall we try and solve it, everybody? Yes, shall we try and solve it? In fact, I have already recorded a video for solution. Yes, some of the most common asking solutions problems, I have already recorded that. It is going to go live on Saturday. Yes, Saturday you will be able to see it, or no. Yes, that is tomorrow. Tomorrow you will be able to see it, okay? Tomorrow that is going to be premiered, so don't forget to check it out. Also, some of the most important inorganic questions I have already recorded. It went yesterday. I see that most of you haven't watched it. Why did you not watch it? Please do go and watch it. All of you, all those students who have doubts regarding this thing, inorganic chemistry, please do watch it. All the most commonly occurring inorganic questions are there. Watch it. 14 marks guaranteed. 14 marks guaranteed. I can assure you that you will not be losing 14 marks from inorganic chemistry, okay? Now, see, in this question they have asked you calculate the boiling point of a solution that is prepared by adding 15 gram of NaCl to 250 gram of water. Kb is also given to you, molar mass is also given to you. Let's do this, okay? Let's do this. Shall we write it? Shall we write it? So what are the things that are given to you, okay? What are the things that are given to you? Let's solve the first one. Here, see what is given to you? WB, weight of solute. Yes, WB is equal to 15 gram. Agreed? Yes. MB, check it out. MB, molar mass of NaCl is also given to you, 58.44. Let's write that down here. MB is equal to 58.44. Please do make sure that even while presenting your paper, you write this, okay? Write it like this. Given data, given WB is equal to 15 gram, MB is equal to 58.44 gram, okay? Now, what else is given to you? You are also given Kb, okay? Kb is what? 0.512 Kelvin kg per mole, okay? 0.512 Kelvin kg per mole. What else is given to you? You are also given the weight of the solvent, 250 gram. Chalo, let's write that also. Wa is equal to 250 gram. Cool? Yes. Now, to find out delta Tb, bacha. To find out delta Tb, we know that we also require I, Van 't Hoff factor, right? I is also required. How do we calculate I? For I, we do not know I, right? We do not know I here. So, let's calculate it, everybody. Are you with me? See, very, very, very easy, okay? Very easy. How do you calculate I? See, the compound that is given to you is NaCl. So, what will NaCl dissociate into? NaCl will dissociate into Na plus Cl minus. Yes, so that means that it is dissociating into 2 ions. Am I right? Na plus Cl minus 2 ions. Is that correct or right, guys? I need you all to be interactive, yeah? I need you all to be interactive. I'm not seeing your chat. If you're not interacting, how will I understand that if you guys have any doubts or not? Huh? I need you all to interact. Please. This won't help. This won't help. Yes. Great. Okay. Alright. Yes. So we have 2 ions. Okay. So that means that I is equal to 2. Correcto? I is equal to 2. Yeah. Great. Now what is our formula? Our formula is, guys, our formula is delta Tb. Okay. First we are going to find delta Tb. So, delta Tb is equal to I multiplied with Kb multiplied with Wb into 1000 divided by, what do we have? We have Mb into Wa. This is the formula. This is the formula, everybody. Do we remember this? This is our formula. Now what do we have to do? Substitute all of these values in this formula. Correcto? Yes? Easy peasy biryani is tasty. Write that down. Easy peasy biryani is tasty. Yes, absolutely right. Absolutely right. Yes, so we are just going to substitute it. Now, if you want to get complete marks, then write that down. Substituting the values in this expression, because I have less space, I'm not writing, but you are going to write that in your examination paper. Substituting the numerical values in this expression, and then you are going to write it down. See, what will you do? 2 into what is kb? 0.512 Kelvin kg per mole, okay? Into WB is 15, yeah, into 1000 divided by what is MB? MB is 58.44 gram into WA is 250 gram. Alright, now calculate, guys. Now calculate. This you calculate and tell me. I am not good at mathematics. Will you do this favor for me? Will you do this favor for me? Come on. Yes. Easy peasy biryani is tasty. Yes. How much for this question? I think this will come for 2 marks or 3 marks max. Okay. Yes, it is necessary to write the given part. Absolutely. You need to present the paper also, na Baba. I know that you all are very much used to writing JEE paper and NEET paper. So you all just want to MCQ, like tick, 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 tick. But what about this? Presentation of paper is also very important, huh? Examiner's mind is already messed up by looking at thousands of paper. They will not work hard to give you marks. You need to work hard to get the marks. So make sure that you present. Make sure that you present, okay? Calculate, guys. What will happen? Calculate, calculate. You know that you are not allowed calculator or log table or anything. So calculate. You have to be better in calculation. Very good, Santosh. Very good. Amazing, amazing, amazing. Absolutely right. Yes, the correct answer is 1.05 or 02 Kelvin. Okay, 1.02 Kelvin you are telling me? Yes, somewhat like this only will be the reason. Okay. Now, let's check out the question once. The question is asking calculate the boiling point. Is it asking elevation in boiling point? Is it asking what is the depression in freezing point? No, it is asking the boiling point. So, to calculate the boiling point, now our formula is going to be TB, not delta TB. Point to be noted, TB I am writing, not delta TB. Point to be noted, TB. So, TB is equal to T naught plus delta TB, correct? What is T naught? T naught is what is the boiling point of pure solvent at 1 bar ATM, okay, at 1 bar pressure. What will it be? What will it be? Rohit Sundar, you are close but a little difference, 373.15, okay? It is 373, not 273, bacha. 373.15 Kelvin plus 1.02 Kelvin, which is equal to 374. Let's say what? 374.17 Kelvin. Is that right? That is your answer. This is your answer. Okay. Clear hai? Express it in Kelvin. Express it in Kelvin. Okay. Always express it in Kelvin. Okay. Yes. Hi Srivatsan. Welcome, welcome. Okay. Now let's take a look at the next question. Now again, point to be noted. What is the difference here? Check it out, guys. What is the difference here? Here do you see that they are asking calculate the boiling point elevation, as in what is boiling point elevation? Boiling point elevation this time is going to be delta TB only. It is delta TB only. This time they are not asking you to calculate the boiling point. They have asked you delta TB only. So what are we going to do? What are we going to do for delta TB? Same thing. In fact, this is going to be even easier for us. We don't have to go one step ahead. Rather, we will stop it at delta TB. Shall we move forward then? Shall we move forward? Let's do this. Alright. So what are the things that are given to us? Again, WB is equal to 10 gram. Let's write it down. WB is equal to 10 gram, my dear student. Okay. What else is given? CaCl2. Okay. Water is 200 gram. That means WA is equal to 200 gram. Okay. MB is given as 111. Okay. 111. MB is equal to 111. Yes. Gram per mole. Gram per mole. Okay. Kb value is also given. Okay. Kb value is also given 0.512 Kelvin kg per mole. Yes. Kb is 0.512 Kelvin kg per mole. Same like this time also we will need the value of I. Am I right? Am I right or am I right? I am right. Okay. Number I we have to find out. What is I, guys? This time, check it out. CaCl2. How will it dissociate? It will dissociate into Ca plus 2Cl minus. How many ions this time? How many ions is it dissociating now? How many ions is it dissociating into? 3? 3? 1 Ca plus 2 Cl minus. So, I this time is equal to 3. Yes, I this time is equal to 3. So, now once again we are going to write here delta Tb is equal to I into Kb into what? Kb into Wb into 1000 divided by Mb into Wa. Substituting the values here, I is equal to 3. What is Kb? Kb is once again 0.512 Kelvin kg per mole. Okay. What is Wb? Wb is 10 into 1000 divided by Mb. Mb is given to you already. It is, yes, gram per mole into Wa is 200 gram. Alright, calculate this and tell me. Calculate this and tell me, guys. What is this? Ca2 होगा नहीं. Ca2 होगा no. Answer, you are right. Yes. Ca2 plus. अच्छा. Huh. Yes. What is the answer? Yes. Done. Already did. Yes. Very good. It is going to be delta Tb is equal to 0.69 Kelvin, and this is your answer. So that means all of you know now how to calculate this. Everybody knows this, how to calculate this. Yes. Yes, guys. All clear? Crystal clear? Clinic all clear? Clinic all clear or not? Come on. See, Agilan, what will happen is, right, let's say that you will need some values of log, okay? Whatever is absolutely necessary, okay? Whatever is absolutely necessary for you to calculate, that will be given to you in question paper. If it is not necessary, if it is expected for you to know it, then they will not give it to you. You will have to know it, okay? Hanji bacha, I have done it, no? I have done it here, no? Ca2 plus 2Cl minus. I have done this, na? I have already done this, Aryan. Yes. Will they give you the boiling point, freezing point of the solution and ask you to calculate the molar mass? No, not really, Rohit. Mostly it is seen that these are the type of questions that they ask you, okay? These are the questions that they ask you, okay? Alright. Coolio? Okay. Clinic all clear, yes? We don't say got it crystal clear, we say clinic all clear. Okay. Yes, Praveen Kumar, like I said, gas constant, R value, no? R value they will give you, yes. R value they will give you, okay? Important question for all the lesson. Miran, this is somewhat similar, no? Somewhat similar. Rest, I expect you to also do self-study, bacha. Don't keep watching videos till the last minute. You have to give time to self-study. Yes? Chalo. Can you course? Of course you can. Why won't you be? Why won't it be? Crocs. Why won't you be able to score 70 plus 70? Read everything, solve the sample paper, solve 5 years previous Q, that's it. Lo and behold, in a snap, you are going to get 70 plus 70. What if they don't? Vikas, then learn the value. Learn the value, what is? Yes, where do we get the slide? After the class gets over, I will send it to you in Telegram group, okay? I will send it to you in Telegram group. Acha, guys, focus. It's time for us to solve now. Okay. Now, this is from electrochemistry. Two half cell reactions of an electrochemical cell are given below. You're given MnO4 minus aqueous plus 8H plus aqueous plus 5E minus Mn2 plus aqueous plus 4H2O in liquid. E0 is plus 1.51V. Sn2 plus aqueous, Sn4 plus, see, this is losing electron. This is losing electron. That means this is our oxidation side. Yes. What is the definition of oxidation? Oxidation is gain of oxygen, loss of electrons. Right? Right? Yes? Yes, everybody? Am I right or am I right? Saying the same thing. This is called being hypocritical. I am one of them. Anyway, right? Losing electron is oxidation. Correct? So, you have to construct the redox equation from the two half cell reactions and you have to predict if this reaction favors formation of reaction of products that are shown in the equation. Chalo, let's solve it. First, let's write the half-half reaction. Srivatsan, focus here first. I will tell you everything, don't worry. I will tell you everything, don't worry. Yes, Pranjal Bacha, let me solve it. I'll tell you everything. Chill karo. Hi, Sharp Sergeant. Chill, everybody, chill. Focus here. Okay. So, let's write oxidation. Where is oxidation happening? Oxidation will happen at anode. Am I right? Am I right or wrong? Oxidation will happen at anode. So, at anode, our reaction is Sn, yes, 2 plus, that is in aqueous, will give you Sn 4 plus aqueous plus 2 electron, right? Okay, this is what we have written, okay. Now, for reduction, okay, for reduction we have, what do we have for reduction? Let's write that down here. For reduction at cathode, okay. What do we have for at cathode? We have MnO4 minus, which is in aqueous state, yes, plus 8H plus 5 electron here. This is going to give you Mn2 plus 4H2O. Alright, yes. Now, see, we have to equate this. This is not equating, right? This is not equating properly. So, what will we do is, here, the oxidation part, let's multiply this with 5, okay? And the reduction part, let's multiply this with 2. Alright, yes. Now, once we do this, what will we get? Chalo, let's write it down. We will get 2 MnO4 minus, because we are multiplying it with 2. Yes, so 2 MnO4 minus, right? Now, 2 into 8. So, 16H plus, correct? 16H plus 10 electron will give you what? Here Mn2 plus, so 2 Mn2 plus, correcto? Then 4H2O, that means 8H2O, right? Right, everybody? And then what did we do with the oxidation one? We have multiplied it with 5. So that means we will get here 5Sn2 plus, oh no plus, Sn4 plus directly, sorry guys, sorry. No singing. We should solve it. 5Sn4 plus, right? And then plus 2 electrons, so that will become 10 electron, correct? Acha, now see, what can you cancel? What can you cancel? You can cancel this, you can cancel this. So what is the reaction that you will get here? Yes, the reaction that you will get here is 2MnO4 minus plus 16H plus 5SN2 plus. This will give you 2Mn2 plus 5SN4 plus 8H2O. Correcto? Yes. Now we know that the E naught value, yes, now we know that E naught is equal to E naught cathode, sorry, cathode, anyway, sorry, what was I saying? I was saying that, now we know that E naught is equal to E naught cathode, E naught cathode minus E naught anode, yes. And we are already given the value, isn't it? The values are already given to us in the question. See, E naught at cathode is what? E naught at cathode is plus 1.51 volt and this is plus 0.15. So that means that 1.51 volt minus plus 0.15 volt. So 1.51 minus 0.15, how much will it give you? Cathode, yeah. Sometimes, you know, these problems, they do happen when I don't sleep well, and I haven't been sleeping very well because of your exam. When will this get over? Very good. Yes, what will we get? We will get plus 1.36 volt. Now, because you are getting a positive value, that means that the product will form. Yes, product will form. Yes, reaction will move forward, isn't it? Reaction will move forward. Easy peasy biryani is tasty. Yes, easy peasy biryani is tasty. Why did you get confused, bacha? Why did you get confused? Huh? Just check it out. See, oxidation at anode. How did you find out which one is oxidation? Oxidation is losing of electrons. Reduction happened at cathode, and we know that what is reduction here? See, it is gaining electron and it is going to its 2 plus state. Yes, here it is at plus 7 state. From plus 7 state it has gained electron, 5 electron it has gained and it has moved to 2 plus state. So bus, reduction is at cathode, oxidation is at anode. OARC, OARC. How will you remember it? How will you remember it? Remember it as O-arc. O-arc. OARC. Oxidation anode, reduction cathode. Clear? Clear? Can I see some fire sign or thumbs up? Anything that makes me feel that yes, I am doing the hard work and it is resonating with you. Let's use a chemistry word. Yes. Is it resonating with you? Resonating with you? Cool. Finally. Oof. Oof. Clinical clear. Great. Amazing. Chalo, moving on. Somebody was asking me, ma'am, please tell us about Colrush law. Acha, theek hai. See, what is the question asking? And see how many years this has been repeated. In fact, even this year, in the sample paper, if you see, there is a question that is related to Colrush law. And I am guessing that most of the time, whatever are the questions that are present in the sample paper, they do come. They do come. You must have noticed that, isn't it? They usually do come. If it is there in the sample paper, it will come. So please check it out. Colrush law is very important. Not only that, Colrush law is so important that you will even get those questions in EMCET. This time also in JEE, there were questions that were related to Colrush law. Achha. Now let me explain what is Colrush law. What is Colrush law? Messy, but give it some time. Let's take a look at it, okay? Give it some time. Let me focus on the paper solving. I will tell you when the time comes, okay? We will be solving some of the organic questions also. Don't worry about it, yeah? Yes? Chalo, acha, listen. See, it says that the limiting molar conductivity of an electrolyte, okay, is the sum of the limiting ionic conductivities of the cation and the anion. Understood? No. Ma'am, what is this? This is very confusing, ma'am. What is this limiting molar conductivity and this conductivity and that conductivity of cation and anion and ionic conductivity? What are this? We don't understand. Sure. Let me give you an analogy. You know that the population of the world is right now at a peak. It's almost infinite. What is it? The population of the whole world has crossed around 8 billion. And right now, India's population is 1.45 billion. Can you even imagine? Look at the population. Yes, that's the population. Now, tell me, how will we calculate population? How will we calculate population? Can I say that the overall population of the world is equal to number of male population plus number of female population? So what is a compound? A compound is basically what? A compound has cation and anion, just like the world population will have male, female. Of course, there are other genders as well, but let's not get into that. But do you understand this? Binary to binary, do you understand this? Male plus female will give you the complete population. Same like this, what do we understand? The limiting molar conductivity. Now, talking about why do we have this word limiting here? Why do we have this limiting here? What I just told you right now is actually talking about a strong electrolyte. We know that a strong electrolyte, you have a strong electrolyte, it will completely dissociate, right? It will go for complete dissociation. Cations, anions. Yes, get it. But what if you have a weak electrolyte? What if you have a weak electrolyte and you want to completely dissociate a weak electrolyte? What are you going to do? You are going to dilute it so much that at a certain point the dilution has reached to its level. After that, it can't get diluted anymore. After that, it cannot get diluted anymore. Let me give you another example. Do you remember that friction? Do you remember that static friction? Static friction is what is static friction called as? Limiting friction. Limiting friction. Static friction also has this term limiting friction, right? Yes? Yes or no, guys? Yes or no, everybody? Yes? What happens in case of static friction? You push something. What happens? Static friction will adjust and say that, I'm not letting you go. You push it even more, static friction will be like, you are not letting go. See, it is limiting. It is limiting, correct? Limiting, yes? Now, imagine this. Here, what is happening is you have diluted the weak electrolyte so much that after this, it cannot get diluted anymore. Just like static friction will also take you to that limit. After that, it's like, bro, I'm done. I surrender. It's okay. That's all I can do. That's the highest amount of static friction that I can provide, right? Limiting friction, same way, limiting molar conductivity. You have diluted it so much that it has reached the limit. After this, it cannot get diluted anymore. Okay. So, now, what do you have? The limiting molar conductivity of an electrolyte. Yes, infinite dilution. You have diluted it so much that it has reached its limit. It cannot get diluted anymore. The molar conductivity cannot increase anymore. Now what are you getting? That is the sum of the ionic conductivity of the cations and the anion. Yes, and the anion. Now do you understand? But a strong electrolyte does not need infinite dilution. Strong electrolyte does not need infinite dilution. You dilute it, it will give you complete dissociation. A weak electrolyte, however, will need infinite dilution for it to break into complete dissociation. Yeah? Gotcha? Yes? So, Pranjal, we dilute it to make complete dissociation. We dilute it to go for complete dissociation. Okay? Yes? Got it? Now? Understood? Amazing. Now what happens is it is given as delta naught m. So delta naught m for AXBY. Let's imagine that the compound that is given to you is AXBY. So X delta naught plus Y delta naught minus will give you will give it to you will give you the limiting molar conductivity, right? Now acetic acid is a weak acid. Do we all know this? Acetic acid is a weak acid. Why do we call it weak acid? Because it does not completely dissociate. However, HCl is a strong acid because HCl diluted H plus Cl minus, H plus Cl minus. Left and right, you will get it. Isn't it? Yes? Sorry, did I say delta? It's lambda. Yes, you are right. You are right. Because I kept saying delta TB, delta TB, delta TB. I said delta again. Yes, it is lambda. Okay. So lambda naught m for AXBY is basically X lambda naught plus, that is cation, plus Y delta naught minus, that is anion. Understood? Understood? Yes? Yes? Understood? Got it? Now, acetic acid is a weak acid. So CH3COH, ideally it should be lambda naught CH3COO minus plus lambda naught H plus. But it's not a strong electrolyte. It's not a strong electrolyte. So directly you will not be able to calculate. Rather what will happen is, if you are asked to calculate the limiting molar conductivity, maybe what they will do is, they will give you the lambda naught for CH3COOK. Okay? Understand this. Maybe they will give you lambda naught for CH3COOK. Maybe they will give you lambda naught of HCl. Maybe they will give you lambda naught of KCl. Now, what is CH3COOK? If I break CH3COOK, let's check it out. CH3COOK. If I break it down, what will I get? I will get K plus CH3CO minus. I also have lambda naught for KCl. For KCl, I break KCl. What will I get? K plus Cl minus. I also have it for HCl. Break it down. Cl minus H plus. Now what will I do? See, what will I do? Cl will cancel, Cl will cancel, K plus will cancel, K plus will cancel. What do I have? CH3COO minus and H plus. And that way I can calculate the limiting molar conductivity. Right? Right, bacha? Am I right? Am I right or wrong? Did you understand what I said? Did you understand what I said? How we can calculate this? This is your Colruyt law. This is your Colruyt law. Clear? Absolutely clear? Come on, give me some fire. Give me some fire. Everybody understood this or not? Give me some fire, guys. Come on. How to score? Shezum Pariti. Bacha, I am taking a session on that only. Please solve this repeated question. I think you will be able to do it. Yes? Few sums. Yeah, I did not get you sums. Yeah, Pranjal, I did not get you sums. Messi, I did not bring you sums today. How about from this, can you try and solve? From this, I'm hoping that you will be able to solve. But I gave you all the concept. Now come on, the hard work is for you to be done, right? I can't do all the hard work, huh? What am I? Now you will tell me, ma'am, please you go and give our exams also, huh? Then I'll have to do that also or what? Will I have to do that also or what? Huh? I won't be able to do that, right? Won't be able to do that. Can you give after the class? After the class what, yeah? After the class, what am I supposed to do? Huh? Okay. Alright, moving on. Chalo. Now, what is lanthanoid contraction? Mention its consequences. Guys, this is one of the most basic question that can be asked to you from DNF block. Please check it out. Tell me what is the answer here. What is lanthanoid contraction? Let's write it down. What is lanthanoid contraction? Lanthanoid contraction is basically, let's write it down. The gradual decrease in the atomic size atomic size of the lanthanoids with increase in atomic number due to poor shielding effect, okay, due to poor shielding effect of 4f orbitals and increase in effective nuclear charge. Is called Lanthanoid contraction. Yeah, am I right? Am I right, everybody? Am I right or not? Screen curtains, absolutely. Oops. Whoa. Did the camera shake a little bit? I just tripped over the mic, this thing, yeah. Just tripped over the mic wire. 1 second, yeah. Camera is okay? Whew, thank God. Imagine I fell down with everything. This will only create the meme of the year just before your exam. Acha. Now, what are the consequences of lanthanoid contraction, bacha? The consequences of lanthanoid contraction also we know very well, isn't it? The consequences of lanthanoid contraction is seen not only in the inner transition elements, but it's actually also seen in the D block elements, in the transition element a little bit more. Exactly, very good, absolutely. Atomic size, we see that the fourth series, right? We see that we see that the third series has almost equal size as the second series of the transition elements. What do we see? Zirconium, hafnium, almost same size. Niobium and tantalum, almost same size. Tungsten and molybdenum, almost same size, isn't it? Do you remember this? Do you remember this, everybody? Yes, 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 yes or not? Acha, remember these names you remember, huh? These names you remember. Zirconium, hafnium, molybdenum, tungsten, niobium, tantalum, okay? Once again, say it with me, you will remember. Zirconium, hafnium, niobium, tantalum, molybdenum, tungsten. Okay? How will you remember it? Let me write this down here. I think. Zirconium, hafnium, niobium. See, this is my name. NB-TA. NB is Nabamita. See, NB Nabamita. Nabamita. See, my name. Okay. Niobium, tantalum, molybdenum, tungsten. Molybdenum, tungsten. Okay, just remember this. See, zirconium, hafnium, Nabamita, and ma'am, wow, mo, ma'am, wow. Okay, learnt it? Sorry. This, if you write it, enough. You will get 1 mark. Now, difficulty in the separation of lanthanoids. Why is there difficulty in separation of lanthanoids? Because the lanthanoids, they have almost similar. All of them, they have almost similar size, which is why they occur in the nature also together and it's very difficult to separate them. Okay, these are the consequences. They have similar properties, they have similar sizes, they have similar chemical properties, and they occur together in the nature. So it's very difficult to separate them. Clear? Alright. A shortcut to remember inner transition. Crocs, please watch the first session of DNF block, no bacha. Abhi, like recently, some days back only I recorded it. You know what? Can I give you this thing? Can I give you tell you something? What you can do is, there are 3 sessions of DNF block, okay? 3 sessions of DNF block that I've recorded. What you can do is watch all the 3 of them together at 1.5x. You will be finishing the chapter within 1.5 hours. Will you do that? Will you do that, Crocs? I have given you the mnemonic also to remember the transition elements. I have given you some mnemonics to remember the inner transition elements also, okay? Alright, please do that, you will remember. For transition series, no, just remember the first one, that is also more than enough. That is also more than enough. First, just remember the first 3D series. How will you remember the 3D series? Sachin Tendulkar, very crazy man, free coaching, Nick's cousin, C-U-Z-N, cousin, okay? Sachin Tendulkar, very crazy man, free coaching, Nick's cousin. What is it? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Easy peasy biryani is tasty. Write that down. Okay? I have given that. I have written that in the DNF block element. Please go and watch it. I promise you will be learning that. Okay? You have learned 3D series. That's it. 3D series, if you know, then you can calculate and you can do it. Don't worry about it. I don't think they will ask you electronic configuration. It's a little too easy for you to achieve 1 mark. Yeah? CBSE is not going to be that kind and generous also. Okay? Lanthanoids. If you want, you can, Malar, because I have given you the mnemonic for that also. In the 3rd session of a DNF block, I have given you the mnemonic there also. Chalo. Next question. Why do transition elements show variable oxidation state? Very easy. Yes. Why do transition elements show variable oxidation state? Because the energy gap between the ultimate and the penultimate shells are too less. Alright? So just like how, remember that topper wala thing that I gave you? Yes, the topper wala thing that I gave you, topper example. Imagine that Hari Krishna, yes, Hari Krishna is, let's say Hari Krishna is a topper, okay? Sorry, every time I cough, just close your ears. Let's say that Hari Krishna is a topper, but just this, you know, half marks or difference, Malar is also the topper, okay? Malar is the second topper. Now for this exam, Hari Krishna was the first, Malar was in the second position. The moment the next unit test came, Malar went to the first position and Hari Krishna came to the second position. Now 3rd time will be their tiebreaker. So Malar is like, bro, what do you think? Huh? I am the second position. I am in the second position. Not at all. See, I beat you. I am in the first position. But now Hari Krishna is also saying, bro, what do you think? Huh? What do you think? You think that you are in the first position? Not at all. This time I am going to be in the first position. So you see, like none of you can't tell them. The difference between their marks is so small that any time it can trip and anybody can get the first position, right? Right? Understood the example? From this analogy, will you be able to remember it if this question comes in your exam? So here we are talking about test marks, but here what do they have? Their energy gap, okay? They have energy gap, okay? Their energy gap is so less that not only the ultimate shell is like, I'm outside, but the penultimate shell is like, don't think too much of you, huh? I'm also right here only, as I can also participate. So that is why they show variable oxidation state. Okay, alright, moving on. Now, define the following: order of a reaction and activation energy of a reaction. Chalo guys, tell me. What are these? What are these? Yes. This has also come, see, repeated 3 years. And this is the minimum that I have written. I'm guessing that it has also been repeated quite a lot of times, okay? Tell me guys, what is it? Order of a reaction, sum of the power of the concentration. Very good. It is the sum of powers of molar concentration. Yes, the sum of powers of molar concentrations of reacting species in the rate equation of the reaction. Sometimes it can be whole number, yes, sometimes it can be 0, sometimes it can be fractional, sometimes it can be positive, or sometimes it can be negative. How is it determined? It is determined experimentally. In Tamil, Sanjay, Tamil theriyad, only English. This is JEE English channel. No, only in English. Okay, no Hindi and all, only in English. Okay. Now, what is it meant for? It is meant for the reaction and not for its individual steps. Not for its individual steps. Okay. It is only meant for the reaction. Got it? Clear? Just the definition they have asked, so it's fine, I think. Just the definition they have asked, so I think you can write it. Now, they have also asked you activation energy of the reaction. What is activation energy? Self-explanatory. No, bro. This is self-explanatory, isn't it? What is it? The minimum extra amount of energy that is absorbed by the reactant molecules to form the activated complex, that is called as activation energy. Is that right? Is that right, everybody? Clear, 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 clear. Come on, clinical clear or not? Tell me. Is it clinical clear or not? Come on, guys. Okay, moving on. Moving on. Acha. Now, a reaction is of second order with respect to its reactant. How will its reaction rate be affected if the concentration of the reactant is doubled or it is reduced to half? Oh my God. Very easy question, right? Yes. What is it? K, A to the power square? A to the power square? Yes, absolutely right, bacha. Absolutely right. So, if the concentration is doubled, if the concentration of the reaction is doubled, the reaction will become 4 times. See, doubled and 4 times. Doubled and 4 times. I will just highlight them so that doubled 4 times. But if it is reduced to half, then what will happen? It will become 1/4. It will become 1/4. By the way, these type of question, a second order reaction, questions related to second order has not only come in your boards but also in your JEE. So please make sure that second order reaction is something that you do not skip. No matter what, second order reaction is very, very, very important. Will you skip it? Will you skip it? No. Okay. Will you skip it? Exactly from NCERT in book. Sandeep, chances are 50-50, bacha. You can't always say that it won't come. Okay. But maybe it is possible that questions directly from NCERT will come, but they will change the numerical values. Okay. They will change the numerical value. Okay. Do you know Tamil? No. Tamil teriyad. That's all I know. That's all I know. Okay. Yes. Arrhenius, okay. Bharani, what am I doing is on 27th, one night before your exam, we will do a complete revision of all the formula. So don't worry. Today, let me take only the repeated questions so that you understand which topics are, which topics you have to focus a little more on. Will you do that? Will you do that? Yeah. Chalo. Messi bacha, why are you asking me to write all of that? All of these are there in your NCERT, no? Yes, I'm telling you the important topic. Just open the book and read that. Just open the book and read that. You will be able to do that, isn't it? Yeah, you'll be able to do that. Chalo, got it? Okay, moving on. Now, when a coordination compound CrCl3.6H2O is mixed with AgNO3 solution, 3 moles of AgCl are precipitated per mole of the compound. Write structural formula of the complex. What is the structural formula of the complex? The structural formula will be this: CrH2O6 3 plus Cl3 minus. Yes, it will be CrH2O6 3 plus Cl3 minus. What will be our IUPAC name? We know that how to calculate, how to write IUPAC name. IUPAC rules, everybody remember. First cation, second anion, alphabetical order, ligand. After that you write the central metal atom. After writing the central metal atom, don't forget to write the oxidation number in the bracket, and if there is a counter ion which is anion, then write that, or if it has a overall charge, then write ion after that. That's it. So what is the name? Hexa aqua chromium chromium is in +3 oxidation state, and then chloride. That's it. Then they have asked magnetic and spin behavior of the complex. Okay, do you know how to calculate magnetic and spin behavior of the complex? Yes, do you know how to calculate magnetic and spin behavior? How do we calculate this? Okay, let me do this and show it to you. Okay, let me do this and show it to you. What is chromium's atomic number? Tell me, what is the atomic number of chromium? Scandium, titanium, vanadium, chromium, 24. Right? Vamsi Krishna, you do not know? Cricket knowledge, do you know or no? Maximum student, tell me. 24. Yes, chromium's atomic number is 24. That means electronic configuration is 3d54s1. Now we know that chromium is in Cr +3 state. If it is in +3 state, then 1 gone, 2 gone from here. That means it is 3d3. Yes, 3dc, 3d3. For 3d3, I have to draw the orbitals like this: 1, 2, 3, 4 and 5. So 1, 2, 3. I have only 3 electrons in D. Yes, only 3 electrons. Now H2O is a weak field ligand. Okay, H2O is a weak field ligand. H2O is weak field ligand. Yes, if it is a weak field ligand, bacha, then will it cause any pairing? Nah, it will not cause any pairing. If it does not cause pairing, that means there are unpaired electrons. That means there are unpaired electrons. Unpaired electrons will exhibit paramagnetic behavior. Yes. Now, what is spin only? Spin only. Yes. Magnetic and spin behavior. What is spin? Spin, how do you calculate? Yes. Nu is equal to n plus 2 root over 2. That means I have 3 unpaired electron. What is n, bacha? N is number of unpaired electrons. So 3. Here I'll write 3 plus 2. Yes. 3 plus 2, 5. 5 into 3, 15. Root over 15. Root over 15 will be what? 4. 4s are 16. So it cannot be 4. That means it will be around 3.89 Bohr magneton. Clear? Is this clear? Yes? Yes, Argya, absolutely. How? +3 oxidation state. How +3 oxidation state? You have forgotten how to calculate oxidation state also, bacha. Have you forgotten how to calculate this thing? What will be the hybridization? Okay, hybridization. Chalo, see, I just told you that H2O is a weak field ligand. If H2O is a weak field ligand, that means no pairing will happen. It will take D2sp3 hybridization. D2sp3 hybridization. Alright? Okay? Okay? Alright? Some of the strong filled and weak filled ligands that are important. Okay. Strong filled ligand, you will have Cn minus CO, NH3. These will be strong filled ligand. Okay. EDTA is a strong filled ligand. Weak filled ligand, you will have I minus, Cl minus, Br minus, H2O, OH minus. Okay. These will be your weak filled ligand. Okay. Do we have Bayer's reagent? Bacha, what are the chapters that are there in your syllabus? Please check it out. No? From there you will understand. Okay. From there you will understand. CO, there are a lot of them. Okay. Even in coordination compound, haven't you watched it? Please watch coordination compound ka this thing also, no? Please, that has a very beautifully I have explained. I have literally taken 6 hours of lecture, one in Hindi, one in English. I have recorded coordination compound for boards. For your boards, I have recorded coordination compound. 2 hours 42 minutes. Again, watch it in 1.5x. God promise you will understand everything. Clinical, clear. I can guarantee 7 marks you will be able to cover. No doubt you will leave anything from coordination compound. Please watch that video, yeah. Please watch that video. If you want, I'll give you the link also. Don't worry. Let me show you. Okay. Should we multiply Van't Hoff factor I every time we have to find elevation? Yes, Gomati, you must. However, sometimes I is also equal to 1. So check it out, okay? Sometimes I is also equal to 1. Bacha, Nandini, Nandini, it is already in +3 state. +3 state, chromium has 3D3. H2O is a weak field ligand. Even if it does not get any pairing, it can still take the D2sp3, no? Right? Because 2D is already empty. 2D is already empty. Or it can, yes, but you are right. Why will it only take 2? Since it needs 6, chalo, let's check it out here. Okay, see. 2 is empty here, bacha. It will go for D2sp3 only, na? Huh? Because already 2 is empty, why will it take the higher level energy shell, bacha? Nandini, you tell me. Nandini, you are asking me, no? Why is it D2sp3 and not sp3d2? See, H2O is a weak field ligand, no doubt. But 2 rooms are empty here, na? If 2 rooms are empty here on the ground floor, why will it take the higher energy level? Why will it take the higher energy level? It will not, it will take the lower energy level. Any tricks? Yes, Fahad, yes, I have given it to you guys. I do not know why you are not watching. Chalo, let me show you guys. Let me show you here. Wait. Let me show you what I have, what I have done. One second. Let me show you. I don't know why you guys haven't watched, yeah? This is your Enlight channel, guys. Yes, this is your Enlight channel. Now see what I have done for you. I don't know why you haven't watched it. There are so many sessions that I recorded and I gave it to you. You guys did not watch only. Super sad, yeah, super sad. Yes. Orchid, D2. D has 5 orbitals. If it is occupying 3 orbitals, still 2 is empty. D2sp3. Don't get confused. See, bacha, see. Check it out. Videos. Go to videos. Yes. Go to videos. Now see. Here. Inorganic chemistry. All board previous year questions. Complete practice I have done. Complete practice, guaranteed 14 marks. Watch this session. You will understand. Okay. Apart from this, coordination compound, one shot for class 12th board only. For class 12th board only, not even JEE oriented. This is absolutely exclusively for board exam. Watch this. Okay. Alright. Will you do it? Now, DNF block. Anybody has doubt in DNF block? Do you guys have doubt in DNF block? See, DNF block 1, DNF block 2, DNF block 3. 3 lectures I have taken. DNF block 1, DNF block 2, DNF block 3. All the mnemonics, whatever you have to learn, potassium chromate, potassium dichromate, potassium permanganate from pyrolusite, or the preparation completely. Everything is in this. Don't skip it. After this class gets over, I need you all for tonight, at least watch these 2 videos before you sleep. Will you do this? Yes, I will take 12th academic this year. Yes, I will. Okay. It is not Mn in O4. No, Pranjal, Mn is in +7 oxidation state. That's highest. Okay. Will you do this? Will you please do this? Please do this, bacha. Divya, all these while I was actually taking care of inorganic because Wasim sir takes care of organic and physical. However, this time he is very much caught up with NEET English and NEET Made Easy. So I have stepped in and I'm taking care of the most repeated question. Okay. I'll help you with your Krishna, focus on the studies, please. Yeah, not in the language right now. Focus on what I'm telling you right now. Okay. Alright, bacha. Yeah. So we are going to do this. Please watch this. This is exclusively for boards. Don't forget. Acha. Now, let me also tell you something. By the way. One thing that I wanted to tell you is, here in this video, if you guys are really having any trouble, if you guys are really having any trouble for JEE or for boards or anything, yes, or for boards or anything. So somebody asked me, ma'am, which one is our Telegram channel? Which one is our Telegram channel? You asked me, right? Where to go for our Telegram channel? Isn't it? Isn't it? Where is our Telegram channel? I will provide in this. This is your Telegram channel. Go to this channel. I will provide you with the PDF of this session after this class in this channel. Okay. Apart from this, you are repeating your crash course, or you want to go for your JEE 2023 that's happening in April. Here, this is where you go. This is where you go. You can come here and you can take the course. Okay. You can come here and you can take the course. All right. Chalo, enough of all of these things that I have told you. Let's get back to our board exams. Okay. Let's get back. Yes, Vamsi Krishna ji. Yes, going. Chalo, moving on, guys. Yeah, let's go to the next topic. Haan, bacha, haan, organic will also be done. Don't worry. Acha, now let's check it out. Giving a suitable example for each. Explain the following. Crystal field splitting. What is crystal field splitting? Where is my pen? Yeah. Organic one shot. Yeah. Tashu Kumari, organic. There are a lot of videos. Will you please check? Organic will take me a lot of time now to prepare, and there is not much time. You only have 4 days left. You would have told me that you have so much doubt in organic. I would have already taken to you. Okay. If you would have told me that you guys are having such great doubts in organic, if you would have told me in my comment section also, I would have done this for you. But anyway, for solutions I am taking, okay? For solutions I am taking, don't worry about it. Solution has a lot of numericals which you will see. Chalo, crystal field splitting, linkage isomerism and ambidentate ligand. Crystal field splitting. What is crystal field splitting? Check it out. See, what happens is basically the metal orbitals are very nicely sitting, okay? But then what happens? A ligand approaches. The ligand is basically that, rude relative. Ligand approaches. The moment a ligand approaches, the metal orbitals are excited, like whoa, ligands are approaching. So they go up in a higher energy state. After going to the higher energy state, now there are mom, dad and the 3 kids, okay? Now the mom, dad, they realize that oops, it's grandparents who are coming. So now their energy level has gone up even more, and the 3 kids who are there, they're like, grandpa, grandma only, no, they will love us, no problem. So they come down, as you can see. See, T2G orbitals have come down, EG orbitals have gone up, and this is your crystal field splitting energy. This is your crystal field splitting energy. Because the ligands are approaching, they split up. Okay, they split up. This is your crystal field splitting energy. I'll give you the notes, you can read it. Okay, I'll give you the notes, you can read it. Now, what is linkage isomerism? Linkage isomerism occurs because of ambidentate ligands. Which ones are ambidentate ligands? Ambidentate ligands which can hold on to the metal with the left hand or with their right hand. Okay. So when more than one atom in an ambidentate ligand is linked with central metal ion to form 2 types of complexes, then the formed isomers are called linkage isomers and the phenomenon is called linkage isomerism. So if you have SCN, what is central metal atom? I'll jump off from the cliff, bacha. What are you asking? What is central metal atom? Tomorrow is your exam and you are asking me what is central metal atom. Are you in class 12 or no? I really hope you are not in class 12. You are asking me this just before. Bro, okay. Central metal atom is the, okay, this is central metal atom, okay. This is your central metal atom. Alright. Yes. This is central metal atom. Okay. Malar, ambidentate ligands are actually unidentate, but they have several donor sites. They have several donor sites. They can be monodentate. Yes, they can be monodentate. They can be bidentate also. Not necessarily. You can't say that. Okay. You can't say that. All right. Anyway, this is your central metal atom. So if it is SCN, then while naming it, what will you write? You will write thiocyanate. Do you see? If it is SCN, thiocyanate. If it is NCS, isothiocyanate. If it is NCS, isothiocyanate, SCN, thiocyanate. Okay. All right. Yes, got it. Got it. You have doubt in organic chemistry. Me too. Me too. Give me a high five. Organic chemistry, I will not be able to help you so much because to be very honest, that's really not my core subject, but no problem. I will at least give you the most important question. Okay. Yes. Hey, no, Pranjal, come on, yeah. Hexadentate and ambidentate and all, don't confuse. Ambidentate is NO2, NCN, SCN, those are ambidentate, okay. Hexadentate and all, they have more number of donor atoms. Ambidentate can hold on to the metal with the left hand or the right hand. Don't get confused now, yeah, baba. Chalo, ambidentate ligand, okay. What is ambidentate ligand? Let's see. Ambidentate ligands have two or more donor sites, okay. For example, see NO2, if I write NO2, it can hold on to the metal with this side, or I can write ONO, it can hold on to the metal with this side also, right? This is an ambidentate ligand, okay? This is the ambidentate ligand, alright? Or check it out, SCN, I can also write it as NCS. It can either hold on to the metal with the S hand or it can hold on to the metal with the N hand. It can hold on to the metal with N hand or it can hold on to the metal with S hand. So this is an ambidentate. This is an ambidentate ligand, okay? Alright? Yes, it can come, okay? It can come in your exam, alright? Yeah, bacha, what am I saying? Yes, they are unidentate. That's the first thing that I said. Some time back only Malar asked me that. Malar asked me the same question and I told you that yes, ambidentate ligands are unidentate, but they have donor sites. They have two donor sites. One that is potential. One that is potential. They act like an unidentate ligand. They act like an unidentate ligand. They have potential. They can also hold on to the metal with the other hand. Understood? Yes. Understood now? Got it? Krishna bacha, please don't spam, yeah? Don't spam, sweetheart. Don't spam. I'm not here to solve your doubts right now. I'm giving you the most important topics. Study, okay? Study, please. Oh, just very fast you are. Don't have to start preparing for class 8. Chill. Take a chill pill. Now, give the chemical test to distinguish between the following pairs of compound. Tell me, ethylamine and aniline. Okay, ethylamine and aniline. Which one is what? Which one is what? Chalo, tell me. What will you give? Huh? What will we give? We definitely know that one of them is aromatic, one of them is aliphatic. Do you understand the difference? Aromatic, ring. Aliphatic, simple. Yes. Aromatic, ring. Simple. Yes. Very good, Amriteshwara. Very good. What will we do? What will we do? We will do azo dye test, because azo dye test will give us a beautiful bright color when it reacts with an aromatic one, but it will only produce nitrogen gas when it reacts with a aliphatic one, isn't it? Isn't it? Very good. Chalo. So let's write it down here. Huh? Let's write it down. Aniline. How do we write aniline? Aniline is, let's draw the structure here. See, the moment I have to draw this, the moment I have to draw these, no, my head goes bonkers. Now I think I have drawn it better. Yes, now I think I have drawn it better. Chalo. So our aniline is this. Yes. Now what will it do? We will have to react it with HONO. (273 to 278 Kelvin, right? Yes? Yes. 273 to 278 Kelvin. What will we get? What will we get? We will get benzene diazonium. Benzene diazonium. What? Tell. diazonium salt. Oof, common names only you will give. Benzene diazonium chloride we will get. Huh? Yes. Now what will happen is here we will have N, here we will have Cl minus, this will be plus, and since it is a benzene, we will have this. Okay, this is also called as coupling reaction if you know, right? Yes, you wrote chloride. Yes, you have to write. Yes, you have to write. Benzene diazonium, that's what I am telling you. Am I live from 1 hour? Is that so? No, but your exam is more important, bacha. Your exam is more important. Acha. Now, what we will do is, we will take this only. Yes, we will take this, and then what will happen is, we will react it to 2-naphthol, okay? Okay, all right, and then here we will have OH. Yes, all right. Now this, what will happen? This what will happen? Double, here triple bond. This will be triple bond, then it will be dilute NaOH, and you have to write dilute NaOH. Then what will you do? Then what we will do is, we will write these two, we just have to add basically, okay? What we have to do is, basically we just have to add this two, okay? So let's draw the structure. Let's draw the structure here. Okay? Wait, I will not be able to see it here. Okay, this is clear? That's it. Okay, that's it. Oh, also. Yes. This is your reaction, okay? So ethylamine will, I'm not getting it, Srivatsan. Okay, all right. Come on, listen to me. Listen. Oi, now everybody, you will ask separate doubts. How will I answer to all of you? Listen, guys. Okay, so aniline, this is your aniline, okay? This is your aniline, all right? So we know that this azo dye test, okay, azo dye test is used to distinguish, okay, azo dye test is used to distinguish. Now we know that ethylamine, it is an aliphatic compound, whereas aniline is an aromatic one. So this aromatic one, everybody, this aromatic one, the aniline, when you make it react with HONO, here you are going to get benzene diazonium chloride. This benzene diazonium chloride, when you make it react, okay, this is basically the dye that you are getting, okay. This is basically benzene diazonium, a diazonium salt that you are getting, okay. This is your diazonium salt, benzene diazonium chloride. This, when you make it react with 2-naphthol, okay, this is your 2-naphthol. When 2-naphthol and this, they react, basically what is happening is, a coupling is happening. See, check it out. You are confused with the structures. Let me show you. This part without the triple bond, just with double bond is here. Can you see it? This whole part. Take a look at it. This is exactly this. Am I right? Everybody? This is exactly this. Just ulta you have done. You have rotated it. And you have written it. Same like this. Exactly this you have to write here. Okay. Exactly this you have to write here. This. Okay. And then you have this. Yes. And exactly this part is your 2-naphthol part, right? Right, everybody? Right, everyone? So that's exactly what we have done. That's exactly what we have done. Yes, studying star, you can consider this for JEE also, because in JEE also these organic questions will come. Okay, all right, everybody, got it? Got it? Clear? Clear? Now I have put it with yellow color. I have put it. See, with yellow color I have put it. Yes, easy coupling reaction. You just had to add them. Just combine them and write the structure. Combine them and write the structure. That's it that you have to do. Okay, that's it that you have to do. And that's exactly what is written. See, aniline on diazotization, that is in ice cold nitrous acid solution, followed by coupling with 2-naphthol in alkaline solution, which is why dilute NaOH forms brilliant orange or red dye. Now, ethylamine will not form dye, it will give you a brisk effervescence of nitrogen gas, okay? It will give you brisk effervescence of nitrogen gas and the solution will remain clear. You will not get any color, okay? No pigmentation will be seen, the solution will be clear, okay? Alright, everybody, got it? Is this clear, everybody? Is this clear, everyone? Got it? Clear? Moving on. Aniline is a weaker base than cyclohexylamine. Let's draw the structure and do it. Let's draw the structure and we do it. Yeah. Amriteshwara, whatever is written in your NCERT, you can follow that also. But I just thought that this is even easier. Okay. This is even easier because you're just coupling. This is even easier. So I wrote that. But if that is what is written in your book, please go ahead. Okay. Please go ahead, bacha. No problem. Acha. Aniline is a weaker base than cyclohexylamine. Okay. Let's draw the structure, everybody. What is aniline? We just drew it. Yes, we just drew it. Aniline, okay. This is our aniline. If I don't write it, I will only get confused. Right. And cyclohexylamine, okay, cyclohexylamine. Just benzene with NH2, not even benzene, this. Acha, now in both of these, what is happening is, very good, Suresh, very good. Here what will happen is, in case of cyclohexylamine, okay, this is our cyclohexylamine, okay. In this case, what will happen is, lone pair availability will still be there. Lone pair availability will still be here, but in this case, what will happen? The lone pair due to resonance, yes, absolutely right, no electrons will be present for donation here, but here lone pair availability, due to lone pair availability, and here resonance will happen, no electrons will be there for donation. Hence, aniline is weaker, and due to lone pair availability in cyclohexylamine, you can say that it is a stronger base. Okay, it is a stronger base. Okay, all right, everybody, got it? Clear? Ayo, my legs are paining now. I'm standing for so long. Chalo, let's quickly finish it, guys. Let's quickly finish it. I also want to go and sleep. Acha, now define the following as related to proteins. Biomolecules. From biomolecules chapter. Yes. Haritanam. Yes. Ligands always act as a Lewis acid because they can donate, and the metals, they accept the electrons. Okay. They accept the electrons. Alright. Yes. Alright, chalo, let's understand peptide linkage. See, in peptide linkage, what is happening is, understand it very easily. You have a alpha amino acid. See, this is your alpha amino acid. This is your alpha amino acid. This is another alpha amino acid. Now, see what is happening is, this, see, COOH, carboxylic acid, right? So, the OH part of the carboxylic acid actually comes in contact with this, okay? Comes in contact with this, from the H from NH2. the one H from NH2 and the OH from carboxylic acid, what happens is these two, they form H2O and they get removed. These two, they get in touch with, they get in touch, okay, they form H2O and it is removed. After the H2O is removed here, what is happening is they form a CONH bond. They form a CONH bond, and that is what is called as your peptide bond. Understood? In solution, numerical, will molar mass already be given? Yes, Arup Roy, most of the time, yes. Most of the time, yes. Okay. Purvi, you're confusing me. Bacha, please, somebody is asking me something, someone is asking me something else. I'm focusing here. Please understand that in a metal and a ligand bond, okay, in a metal and a ligand bond, all right. We are going back to coordination compound. Listen to me. A metal will always act as an electron acceptor, okay. Ligand will be the donor. Ligand will be the donor. Ligands, they act as Lewis bases. The metals, they act as Lewis acids. Am I clear now? Am I clear now? No confusion here? Yes? No confusion here? Everybody got it right? Got it? Clear? Amazing. Moving on. Peptide bond, everybody got it? Did you all understand peptide bond? Yes? Understood peptide bond, everybody? See what is happening. The OH from carboxylic acid and one H from NH2, they are coming together, forming H2O, getting removed. Once they get removed, you get a CONH bond, which is your peptide bond. You just have to write it down in English in a sentence. That's it. Okay, that's it. Now, primary structure. What is primary structure? Let's understand. Proteins may have one or more polypeptide chain, and each polypeptide in a protein has amino acid, alpha amino acid. Achha, write that down also. Huh? They have alpha amino acids that are linked with each other in a specific sequence, and it is the sequence of amino acid that is called as primary structure of the protein. What is denaturation? Denaturation is very easily, whenever you introduce proteins to heat, what happens is the shape, the structure, it just gets destroyed, and after that they are not functional enough. That's called as denaturation. Okay. Have you seen, if there are any North Indians, may I speak about it, rajma chawal, right? The North Indians, they eat a lot of rajma chawal. And you know, if sometimes what happens is, let's say that somebody has forgotten, they had to soak rajma to be able to cook it the next day. Let's just say that they have forgotten to soak rajma. Do you know how you can denature it? Do you know how you can denature it? You pressure cook it. You boil it. Yes. Give it 2 to 3 whistles. Once you give it 2 to 3 whistles, after that, do you know what happens? Give it 2 to 3 whistles, and right then and there, just put it into ice cold water. Hot, ice cold water. Hot, ice cold water. Rajma, the protein in the rajma gets destroyed, which is why it becomes soft. It becomes squishy, soft. Okay. So that's your denaturation. All right. Moving on. What are the products of hydrolysis of sucrose? Equivalent what? Equivalent glucose and fructose. Right? Isn't it? Yes. See? Exactly. What will you get? You will get an equimolar mixture of glucose and fructose. Don't forget to write the reaction, huh, Baba? Please do write the reaction. If you don't write the reaction, maybe it can happen that you lose a mark, okay? So do write it, huh? Do write it. Acha. Write the chemical reaction to explain coal-base reaction. What do we do? This is coal-base reaction. What do you get? Salicylic acid, isn't it? You get salicylic acid, very easy. You write a phenol, take a phenol, treat it in sodium hydroxide. Treat it in sodium hydroxide. What will happen? What will happen? This H will get removed, okay? This H will get removed because there will be an attack of OH minus here. If OH minus attacks here, then it will form H2O and it will get removed. And sodium, Na will get attached here. So you get sodium phenoxide. Getting it? Understanding what I'm asking? Understanding what I'm asking? Understanding what I'm telling you, everybody? Yes? So OH minus will attack here. This H will be removed from here. This H will be removed from here. You will get H2O. Yes, now sodium will attach here. So you get sodium phenoxide. From here, you will again, now you will treat it with H plus and CO2. What will you get? OH and COOH will get attached here. So orthohydroxybenzoic acid, which is nothing but salicylic acid. That is your Kolbe's reaction. Okay, that is your Kolbe's reaction. Kolbe's reaction has repeated a lot of time. One more thing that you have to forget, you don't have to forget, is Riemer-Tiemann reaction. Riemer-Tiemann reaction has been repeated so many times, and in fact even in this year's sample paper you have questions related to Riemer-Tiemann. So Riemer-Tiemann, make sure that you properly read it and go. Make sure that you do not forget Riemer-Tiemann, because 100% it may come. 100% it may come, okay? Now, in the following pair of compounds, which one will react faster by SN1 mechanism? Obviously this. Obviously Cl. That will react faster by SN1 mechanism, as it is a tertiary halide. Yes, and it produces a stable tertiary carbocation. What do we know about SN1 mechanism? For SN1 mechanism, we know that it is 3, 2, 1, isn't it? Third degree. Tertiary carbocations are most stable. Okay, tertiary carbocations are most stable. Got it? See, Riemer-Tiemann 2012, 2014, 2011. There are chances, high chances that it will come here this year also. High chances that Riemer-Tiemann will come this year also. After 2011, there has been a gap, so it may come. Okay, it may come. So please study this. Riemer-Tiemann, what do you get? Riemer-Tiemann, Kolbe's reaction, you get salicylic acid. Here you get salicyldehyde. Yes, you get salicyldehyde. Okay, see, so you take this thing, okay, OH plus CHCl3. Again, NaOH. NaOH is here as well. NaOH is here as well. Once you get NaOH, what do you get? ONa. Same thing, ONa, and then here you have CHCl2. One more time NaOH, ONa, CHO. Now after you treat it with H plus, what do you get? Salicyldehyde. Understood? Easy hai? Easy peasy biryani is tasty. Come on guys, say it. Come on guys, say it. GMC NEET, I think Divit has already answered your doubt, okay? Divit has already answered your doubt. Sweetie, I have already told you, you haven't watched the whole session. You are only coming at the end and you are asking me the same thing. Please watch the session, whole session. Oh, we are done. Okay. We are done. So guys, with this note, it's time for me also to have my dinner and have a nice sleep, because tomorrow again I will have to record another session for you. Don't forget to watch it. Solution chapter most important numericals will be coming up tomorrow. Sunday there will be a strategy based session. I will tell you all about the most important topics that you don't have to forget, and Monday we will do a quick revision of all the formula. Okay, Monday we will do a quick revision of all the formula, and Tuesday you are going for your exam. So all the very best everybody. Study well. Don't forget to at least complete your inorganic parts today only. Okay, today complete your inorganic part, bacha. Chimki, please get in touch with the channel, subscribe the channel and click on the bell icon so that you can remember. Hari Krishna Gamer, bacha. Aaj ke liye, I think it's enough. Yeah, I'm very sleepy and tired now. Will you please study it? Will you please study it? Okay. Alright. Electrochemistry also done, na bacha. Electrochemistry also we have done. Okay. Electrochemistry also we have done. Chalo, if you want to stay in touch with me, you can connect with me on my Instagram, that is Nabamita_Nobita. Do not forget to join our Telegram channel. I will be providing you with the notes right away. So thank you so much for joining the session. I hope you all the very best, and I hope that you all study and you all ace your exam. So lots of love and good night everybody. Bye bye. See ya.